All right, what we have here is a collection of data that we've gotten from an employer. And what we want to try to do is figure out how many applicants we have and some other things. What they've done is divided them into three groups: people that have copywriting skills, graphic design skills, and ink building skills. So they've given them, link building skills. So we have C, G, and L will be our categories that they're in. And what we want to do is use this information to determine various questions they have afterwards. Like, for example, how many applicants are skilled in copywriting only? How many people have exactly 2 skills, etc. So what I'm going to do is use this information to create a Venn diagram. Here's how it will work. Let me make myself some space. Give yourself a lot of space. You're going to want to make 3 big circles, all overlapping. I'll label them C, G, and L, just like the example tells us. Now what you want to do is you want to work these in the most extreme situations first, the most limiting. So for example, the way you want to start this particular one is somewhere in the middle. I would like to start where all 3 overlap to begin with. So let's take a look. If I look, 2 people have all 3 skills. I'm going to put a 2 in here. That 2 is shared by all 3 circles. Then it says 4 applicants have none of these skills. So I will put a 4 out here. Oh, don't forget, the U is not a big deal, but I usually put it anyways. So I've got my first piece of information. I've got a 2 inside of there. I've got 4 people that have no skills. Let me scroll through here. Now I'm going to look for more limiting things. So I'm generally going to work myself from bottom to top. So let's take a look. I see that 6 are skilled in both L and E. Let me get 6 are skilled in both L and E. So 6 people can do both G and L at the same time. So come down to the picture. Let's look and see where L and G overlap. That's this region right here. This is the L and G overlap. However, we already accounted for 2 people. So I know 6 people goes into this overlap total. 2 people are accounted for. That must mean that there is 4 people in that spot. So these 4 people have the skills of G and L, but they do not have the skills of C. Let me go back now again. 5 are skilled in both C and L. Let's take a look at C and L. C and L, the region for C and L is right here. That's a total of 5 people. I've already accounted for 2, so I will put 3 more. And then last, the G and C, I haven't seen anything connecting them, so let's see if we have something. 9 are skilled in both C and G. So I look here, this circle, this overlap region here has 9. I've already counted for 2, so there is 7. Now we're left with filling out these regions here. Now come back up. 15 can do L. So let's take a look at L. 15 can do the entire L circle, but if you'll notice, I already have 9 people are already accounted for in L. That must leave 6 left over, since the whole thing is supposed to add up to a total of 15. Now let's move on. 18 people can do G. So let's take a look. If 18 can do the G circle, I've already got 13 people accounted for, so that must mean I have 5 here. And then finally, let me see how many people can do C. 17 people can do C. I've already accounted for 12 of them. That must mean that there are 5 people out here. So be careful in how you're looking at these. All these people in overlap regions can do more than one job. all these people in these regions way out here can do only one job, and these 4 people out here can do 0 jobs. Now let's look at the questions that they have asked us. For part A, how many people are skilled in only copywriting? So that's this C region right here. These 5 people can only do copywriting. How many applicants have exactly 2 of the 3 skills? That's these people here in this region between C and L, but not including G. So those 3 can do 2 jobs. In particular, they can do C and L. These 7 can do C and G, and these 4 can do L and G. So adding these up, we're going to have 3 plus 7 plus 4. That'll be a total of 14. And then finally, part C is how many people are in the group altogether. That's where we add up all of these numbers completely, because what they've done is they've organized everybody according to exactly how many tasks they can do. So let me first start with C. That's where I'm going to have my 5, 7, 3, and 2. Then let me add to that the G items, 5 and 4. And then finally the L. And don't forget the 4 people that can't do anything. And let's add them up. I have 12, 15, 17, 22, 26, 32, 36. And so this is how you do a survey. Use these Venn diagrams to help you out. This is very useful. You will have maybe sometime in your life where you'll have to do these things if you're trying to get into graduate school. Some of them ask questions like that. All right, we have ourselves another survey. Here, instead of giving it in terms like I did before, this time I'm giving it in terms of intersections and things of that nature. Here, I'm dealing with T, F, and L, and I'm going to draw my picture. Draw the same picture every time. You'll find that it is quite useful to draw one picture for just about everything. So here I'm going to have a T, F, and an L. Give yourself lots of space. T, F, and L. Now the general rule here is to take and do the most restrictive things first. So that's where the first thing I'm going to attack are these last 2 items. This item here that says 3, these are the people that can't, that are in none of these sets. It's not in T, it's not in F, not in L, so it's in none of them. That means that out here is 3. Next, the number in the intersection of all 3 of them is 5, so I know that there goes a 5 inside of there. Working my way up again, the number that are in T intersected with L is equal to 6. Notice that this is T, this is L, and the intersection is right here. It's 6, but I already have accounted for 5. That means what must go into this spot is a 1. Now F intersect L has 10 items. F intersect L is this oval kind of shape here. It says I have 10, but I've already counted for 5, so that means I must have a 5 in that spot. Next, T intersect F has 9 items. T intersect F, that's this region right here. I've got 9 items, 5 are accounted for. That means a 4 must go into that spot. Moving on, the number of items in L is 13. So here's the L circle. I've got 13 items total. I've already accounted for 10, 11 items. That means I must have 2 right there. For the T, well, I take F next. F is 16. I've already got 5, 10, 14 accounted for. That must mean that this is a 2 right there. And then finally, the number of items in T is 13. I have 9, 10 items already, so there's a 3 of them there. Well, the question asks then, how many people are in his group altogether? So this is where you add up every number that you see. So I have 3 plus 1 plus 4 plus 5. That's the T circle. So I've dealt with all these. Then I'm going to add 5 and 2. And then I'm going to add this 2. And then don't forget the 3 outside. That adds up to 8, 18, 20, 25. And that's the answer to the question. Here's another example from the textbook. I would, if I could, do the work to the side, but I think it's going to be too many people, or I'm going to need more room than that, and you need to give yourself plenty of room for these problems. Here is the same situation again. This time I have 3 items. I think we'll check out the letters in a second. What do we have here? All right, we have drywall, roofing, and electrical work. So we're using D, R, and E for these designations. So D, R, and E. My D looks like a P, so I'm going to fix it to be more D-like. All right, so now we'll do the same thing that we did with all the other ones. We're going to work the most restrictive first. So if you look, 4 can do all 3 of them. So that means I'll have a 4 in the middle. And we'll work our way up if we can. 4 can do both R and E. So R and E, this is in here. 4 can do R. Well, I've already counted for 4, so that must mean that I have 0 left there. Moving on. 5 can do both D and E. So D and E is down here, so this is the spot we're talking about. 4 already accounted for, so I have 1 outside of there. Now, we're kind of stuck here because look, 6 of the 9 can do D. That would be great. I'll have a 6 here, but the only problem with it is I have that little space right there. I don't have any knowledge of how many people can do D and R. So what exactly am I supposed to do with this information? How do I work this? Let's take a look again. 5 can do both D and E. There's our 5 right there. 4 can do both R and E. So they neglected to give me R and D. I need to fill that out. Well, we know there's a total of 9 workers. That helps. And I don't see anywhere else where they have relationships between these things. So in situations like this, you have to use logic and reasoning to try to get these blank spaces, and it can be sort of hard. We know that 6 of the 9 can do D, so once I find this spot here, I'll know what can go into this spot right here. Next we notice, oh, I jumped too far. Come back up here, look here, 7 can do E. Well, I can fill out E because I have 5 already, so I know that 2 go into here. 4 can do R. Well, this is interesting. Look, I've already got 4 accounted for, so I know that there's going to be a 0 and a 0 here. So you have to infer this stuff. And then finally, D. 6 can do D. So in here, I've already accounted for 5. That means I have a 1 right there. Now there was a total of 9 people here. If you add up these numbers, 1, 2, 6, 7, 8, that means that there had to be exactly 1 person on the outside. Let's go ahead and answer the questions that they've asked. For part 1A, exactly 2 of the 3 skills. That's these people here, this 1, this 0, and this 0. So you're going to have 1 plus 0 plus 0, that will equal 1. For part B, how many people have none of the skills? We already did that one. Part C, no more than 1 of the 3 skills. So we're looking for people that only have 1 or 0 skills. So if we look at the 1 skill people, that's this 1 here, that's that 0 there, that's that 2 there, and the 0 skilled people is that 1. So we have 1 plus 0 plus 2 plus 1. It looks like a total of 4 people for that. And then D, at least 2 of the 3 skills. So how many people have 2 or 3 skills? And that's down here. That guy has, or that person has 2 skills. This 4 people have all 3 skills. So 1 plus 4 will equal 5. For question 2, which skill is common to the greatest number of workers? Well, the greatest number of them look like they can do electrical work. How many possess that skill? We have 4, 5, 6, 7. So we have 1 plus 4 plus 2 equals 7. And oh, there was actually 2 questions here. So E was the one that gave the most workers. Here's a problem from your textbook. What we want to come up with is the size of each of the sets listed, and they've already completed the Venn diagram. So for part A, for example, they want the number of items that are in A intersected with B. Well, A intersected with B is this guy right here. Well, not exactly the listing of them, but the number of them. So I know that there is 1 in that spot. For B, A union B is going to be everything inside of both of them. So I'm going to have 3 plus 1 plus 7 equals 11. Now let me erase some things here so that I can do some other items. A intersected with B prime are the items that are in A but not in B. So that's these items right here. These items that are in A but not B, and we know there's 3 of those. Similarly, if we want the number of items that are in B but not A, we're looking at this collection right here. And that says there's 7. And then finally, the last one says that what is the number of items that are neither in A and they're not in B. So if they're not in A and they're not in B, that must mean that they're outside the circles. So that would be this number 5 up here. I don't think I actually put what these equal. This was the number of items in A union B. This was the number of items in A intersect B prime. This was the number of items in A prime intersected with B. And this was the number of items in A prime intersected with B prime. All right, in this next problem, look at part A. They've already started off with the most restrictive possible thing you could have, and that's the number of items that are in the intersection of all 3. That's going to be this guy right here. That's equal to 1. That one is always the easiest to find. Next, what this is the number of items that are in A and B, but they're not in C prime. So where are we talking about? They're not in C. So they're not in here, but yet they're in both A and B. That would be exactly these 2 right there. Next, we have the number of items in A intersected with B prime intersected with C. So these are the items in A and C, but not in B. So let me cast aside B, and now let me look for the items that are not in that, but in both A and C. That's these 4. Moving on. As you could probably have guessed it, now I'm going to do the number of items not in A but in both B and C. So I'm going to ignore that circle, and the items that are in B and C then are 7. Moving on to E. The number of items that are not in A and not in B, but yet are in C. So I want the items that are not in A, not in B, but in C. That would be this guy right here. That's shared by no other one, it's by C by itself. So there's our 5. Now we're going to do A intersected B prime intersected with C prime. So these are the items in A, but not in B and not in C. That would be those 3. G, the number of items in A prime intersect B intersect C prime. As you might have figured, we want items in only B and not in A or C. There's our 6. And then finally, what do we have last? We have H, the number of items that are not in anything. That would be these guys out here. Recall the following formula. The number of items in A union B is equal to the number of items in A plus the number of items in B minus the number of items in A intersected with B. I don't know what the name of this is, but it does give the size of a union. It's an important formula, as you can imagine. And so now let's go ahead and do some examples exploiting that formula. So this is how we use the formula. I'm going to write it out each time. The number of A union B is the number of A plus the number inside of B minus the number in their intersection. And I'll basically fill out the numbers that I know. So let's start. I know that n of A is 16, n of B is 28, and n of the intersection is 5. Well, that makes it pretty easy for me. All they want me to do is all they want me to say is what is the size of A union B, and that of course is what they're asking. So 16 plus 28 is 44 minus the 5 equals 39. This example is a little bit different. They're asking us to find the intersection this time, the size of it. So once again, I'll write my formula and I'll fill out what I know, and then whatever is left is what I'm being asked to solve for. So what was the size of A? That was 20. What about the size of B? That's 24. I have the union, that's 30, so I have the right side. So they want the size of the intersection of those two. Well, let me simplify a little bit. Now this is an equation to be solved, so I'm going to subtract 44 from both sides. So now I have, well, the negative of what I want. You can fix this by dividing by -1. And so I'll see that 14 is the number of items in A intersected with B. One last algebraic problem. Let me write it up again. N of A union B is N of A plus N of B minus N of A intersected with B. Let's put in what we know. I know N of A is 20. I know that the intersection is 6 and the union is 30. So they must be asking us to figure out the number of items that are in B. Let me combine my numbers on the right side. So if I want to get N of B alone, I'll simply subtract 14 from each side. All right, another use of the Venn diagram is given in this problem here. They tell us how many items are in the universal set, and they tell us a few other things. And notice we only have A and B to deal with. So this is a smaller example than what we've been doing. We have an A circle and I have a B circle. Let's fill in the information that I know. The number of items in A is 25. Oh, here, this is it. Number of items in A intersect B is 5. So now I can use this number of items in A is 25 to put a 20 into that spot. The number of items not in B is 30. That's interesting. So if you look at this here versus this, that means that there are 13 people in B. So notice this, n of B equals 13. And that's from these two. I'm making that inference. So if I know there's 13 people, I already know that 5 people in B are accounted for right in the middle. So with that said, where's my cursor? With that said, this 5 in the middle tells me that there has to be 8 here. I'm not quite done yet. They want us to fill in all regions. There is a region out here. Remember, there's 43 people total. Inside of here I have 33 people. So that must mean I have 10 out here. All right, this one is like the previous problem, except it's more complicated. We have 3 sets, so I'll draw all 3 of them. This is just practice in filling these things in. And as usual, start at the very most restrictive things that you can. So here, this right here is the number of items that are not in A, B, or C. So we can put a 2 out there. Now the next thing that I want to target is right in the middle here, if I can. And I see that I have it right here. The intersection of all 3 has 6 items. Now once I have that, I'm going to go and look for intersections of 2 things, like this next one. A intersected with C has 26 items. Oh, actually let me draw these. A intersected with C has 26 items. So A and C intersect right here. If I've already got 6 there, that means there must be 20 in that spot. So I think what I'll do is I'll scratch these off as I use them. B intersect C has 7 people. So there's B intersect C is right in this region. So that must mean I have a 1 there because I've already got 6 accounted for. Oh, now they get sort of tricky. Well, the number of items in C is 40, and I already have 27 accounted for. That's going to leave 13 out there. A intersected with B has 21. Here is A intersected with B. So since I already have 6 accounted for, I can put a 15 up into that spot and cross that out. And now the items in A that are not in C is 20. So the items in A that are not in C is 20. That must mean that outside of here, I've got 20. I would like to put a 20 here, except there is a 15 to deal with right here. So 20 minus 15 is 5. B intersected with C prime. So the number of items in B that are not in C. So this is B right here. Now I want to take away the items that are not in C. So that's those. So on 25 minus those 7 is 18. So I have 18 that are in B but not in C. Now I've got 15 here, so that must mean that a 3 goes into that spot. Oh, I made a mistake. So the number of items that are in B intersect C prime is 25. So 25, let me add these up here. So I have 25 between this and this. because I have to take away those. So I know 25 goes here. Well, I've already got 15 accounted for. That must mean that there's a 10 right there. Here's another question. This one is more of a word problem. We have 240 Microsoft Windows users. So what they've told us here is that the size of the universe is 240. Now we've got a breakdown here. We've got Windows users, let me see, they use Chrome and then Internet Explorer. These are the percentage breakdowns. To get the number of people that do this, the number of items of people that use Google Chrome, I guess I'll use a G. The number of people that use G for Google is 65% times 240, or that's 0.65 times 240, and that number is 156. So the size of G is 156. Now the size of I, which I'll use for the I for Internet Explorer, that's 35% times 240, or you could simply subtract 156 from the 240 to get this number. It looks to me like we're going to have 84. Now what they want is they want the number of people that use both Chrome and Internet Explorer. So if we draw a picture of this, there's G and there's I. They want to know this thing in the middle here. How many are in the overlap of the two? 95% use at least one of these two. So 95% use either G or I or both. What is 95% times 240? That is equal to 228. And guess what they just gave you there? That is the number of items that are in both G, or in G union I, and that's 228. So now we can go the number of items in G union I equals the number of items in G plus the number of items in I minus the number of items in G intersected with I. And that's the last thing is exactly what we want. The number of items that are in G was 156. In I was 84. This is the guy that I'm looking to get. And then the number in G union I we know is 228. So I will subtract 240 from both sides. And I have negative 12 equals negative n of G intersected with I. Once again, I can divide both sides by negative 1. And I get the size of G intersected with I, that's the question, equals positive 12. Here's another example, but this one is more of a word problem like the previous one. I am going to just use I'm going to use P for Paul Simon. Put a P there, and then Art Garfunkel, I will use the letter A. So we're going to do the same thing as we did previously. I'm going to see if I can fill out all the regions. So take a look. It says 5 on both Simon and 5 on which both Simon and Garfunkel sing. That means 5 songs that they both sing, so 5 is in the overlap. Now 7 on which Simon sings. So we have 5 already for Paul Simon. We know it's a total of 7, so this has got to be a 2. And then 8, on which Art Garfunkel sings. 8, I've already got 5. That must mean there's a 3 here. In addition, I can fill the outside out, because 15, on which neither Simon nor Garfunkel sings, is right there. And now if we start to answer questions, let's take a look at part A. How many of her compact discs feature only Paul Simon? And that's this number right here, this 2. How many feature Art Garfunkel only? And that is this 3 right here. How many feature at least one of these 2 artists? So that would be all of these bubbles. At least one of them is actually the union of the 3. So we're going to have 2 plus 5 plus 3 for that. And then D, how many feature at most one of these artists? So that would be 1 or 0. At most means less than or equal to. So 0 would be 15 plus 2 plus 3 for a total of 20. Okay, in this last example, we have 3 possible sets. We have love, prison, and trucks. And so I'm going to make a diagram with L, P, and T. As usual, make sure you give yourself plenty of space in the overlap regions. So we have L, P, and T. Love, prison, and trucks. Now I've got to try to find the most restrictive thing I can find. So I want to look, how many songs are about love, prison, and trucks all in the same one? Are they in there anywhere? Well, I'll tell you what, let's put down the things that we do know. The first one right here, 12 songs about a truck driver who is in love while in prison. So what they did is they gave the number of items between love, what is this? 12 songs about a truck driver who is in love while in prison. So they gave us a truck driver in love while in prison. And that was a total of 12. So there's the intersection that I want in the middle. Now I can start doing stuff with it. Next we have 13 prisoners in love. So the number of prisoners in love equals 13. So let's take a look. I have my prisoners in love would be this section right here. I know I have 12 already, so I can put 1 in that spot. So I basically, maybe I should cross these out as I use them. So now this 28 about a person, that's just a person in love. That's this whole circle should be 28, but I don't know this spot just yet, so I'm going to hold off on that. How about, so 2018 about a truck driver in love. So I said the number of T intersected with L was 18. So T intersected with L is 18. Well, I've already got 12 in their intersection, so that must mean I have a 6 in that spot. Let me put it. The number of people in love is 28. So I have yet to use that. I'm going to put a circle around it to let me know I haven't used it yet. Now we have 3 about a truck driver in prison but not in love. So the number of items in truck driver and prison but not in love. So T intersect P intersect L prime. That would be in this spot actually, because that would be the stuff outside of there. And we are told that that is equal to 3. So that spot gets a 3. Moving on, so let me go ahead and I'll just do that, it's easier. 2 people in prison who are not in love and do not drive trucks. So the number of people in prison, not in love, not driving trucks, that one is equal to 2. So prison, not in love, and no trucks. Well, that's these guys right here. So there's a 2 that goes into that spot. 8 about people who are out of prison. So they're not in prison. So we've got the number of not in prison, are not in love, intersect not in love, and do not drive trucks. And that is equal to 8. So as we usually do, there will have an 8 out here. I've got just about everything I need. 16 about truck drivers who are not in prison. So the number of items in truck drivers intersected with P prime. See if you can follow my yellow thing out here like this. Should be a total of 16. That puts 10 into that spot. And now we can actually start to answer the questions to the problem. A, how many people were surveyed? You simply add them all up. Oh, you know what, I'm missing one. I think that was this guy, 28 people in love. I've already got 19 accounted for there. That must mean there's 9 in that spot. Now let me go ahead and do all these answers. So for first one, how many people were in this all together? Add up every number. 9 plus 1 plus 6 plus 12 plus 2 plus 3 plus 10 plus 8 for a total of 51. For part B, truck drivers. How many truck drivers were there? Add up this circle for truck drivers. 10 plus 6 plus 12 plus 3. That would be 31. For part C, prisoners. How many prisoners do we have? So that's these numbers right here. That's 18. Truck drivers in prison. That's these ones right here. That's 15. People not in prison. So who is not in prison? So E. So count everything outside of this prison circle. We have 9 plus 6, that's 15, 25, 33. For F, people not in love. So here's the love circle. Count these out here. Alternatively, you can add up the number in the love circle and subtract it from 51. That's another way to do it. Otherwise, we just count the numbers outside of L. So I have 2 plus 3 is 5, plus 10 is 15, plus 8 gives me 23. Part G is a prisoner in love. That's these. That's a total of 13. And then finally H, exactly 2 of the basic themes listed. That would be this, this, and this, for a total of 10.